Okay, so today what we're going to do is we're going to delve a bit deeper into graphics and how to use them, specifically how to use windows and screens in Java in order to get different types of input, like mouse input or keyboard input. And then we're going to delve a bit more on how to make it fancier, how to use these inputs in order to do different actions, like making button presses, and how to display various other different types of data structures onto a screen. And then for our next and final class, we'll essentially do a big giant review of everything we've done to this point. All right. So so for those that weren't here, yes, what you did last time was we essentially cover how to make a separate screen, how to make an extra window in Java, and essentially how to color and how to present an actual window of graphics rather than simple text. So we run it. So that what we did yesterday was essentially we made it so we can actually create a board that's a window. And this is our board. Let me just resize it. And so we made it so that every time the player picked columns, it would actually show up into the board. In order to do this, you need two things. You need a frame, you need a panel. Frames are, if you remember last time, essentially the actual window itself. It's the frame, like it's like a picture frame. And then the panel is the thing that is actually stored inside of the picture frame. This is what you put inside of the frame, and this is what actually shows the different colors, the different images you want to show. And in order to actually use these, you have to call them. When you construct them, they become objects known by whatever name you give them. This is an object called connect for panel. This one is an object called connect for frame. So if you want to use it, you need to call this object by its name so the computer knows, okay, you want to use this specific object. So specifically when we go to the main program or the program that actually is capable of like running, this is the program where you start from. All right. So when you get to the part of the program that you run from, you need to create this object, usually by creating a variable that has a given type of that frame, and creates a new object of that frame, puts it inside this bucket. And then after you do that, this frame, usually what happens next is we then create the panel inside of the frame. You could try to implement all in the main, but it's much more efficient to do this way because the panel itself doesn't actually have anything to do with the main. Only the frame actually is going to be affected by the main in any way. The panel itself is instead affected by the frame. So essentially the main creates a frame, and then the frame will create a panel, and then the panel will create images. So that's what we learned last time. We learned how to essentially create these images. Next, today what we're going to do is we're going to learn how to use this window to create inputs. Lots of times in computer programs, rather than simply typing, you want to be able to use their mouse. Or sometimes you don't want to use a terminal, but rather just any keyboard input at all, whether or not it's actually typed into this bottom area. You want any keyboard input. That's also what we're going to be doing today. So specifically, the way Java implements the mouse inputs or the keyboard inputs is with an interface called mouse or keyboard listener, depending on which one you're using. We'll get mouse listener first. In order to use it, you have to go to the panel, the thing that actually is not the frame. You can implement it in frame, but you generally implement in the panel because that's where you do the drawing and stuff. So that way, whenever you have to go cross-reference between like the position of where you drew the buttons, it's much easier to find. So you put it inside the panel, and now Java knows that this panel is implementing, or in other words, is using a mouse listener. And when you implement it, you'll auto create the mouse listener methods for you at the bottom. Specifically, the different methods just simply correspond to different moments in time. When the mouse is pressed, when it's released, and here mouse click means it's pressed and released. So after both of those events have occurred. We have mouse entered, which is when it enters the window and when it leaves the window. Most of the time, the only ones we really care about are mouse clicked. Although there are definitely many situations as well we want to use one of the different ones. But for those, it's like the type of code you're using will be like very similar to what you're doing with mouse clicked and the other ones. You're simply just changing when it happens. So specifically, if you want to use the user input, you have to use the input that is given to you. The way the mouse listener works is that every time you click the mouse, it will run a method called mouse clicked. And this mouse click method will take in the mouse event, your mouse click, as an input. And then you can use this variable, this object with all the data that it contains to then do stuff with it. Because mouse event is an object, essentially this mouse event is a type of variable that can hold multiple other data points. And specifically in this case, it can hold the most important ones we care about is X and Y, the X position of the mouse in the window and the Y position of the mouse. This will only run if you click inside the window. If you click outside of it, it won't give you any numbers and nothing will happen. It won't even run. So you have to remember that. It only works if you click inside the window. So after you get X and Y, let's say you want to use X and Y and figure out whether or not the user is pressing a button in like the top left corner. Well, in order to do that, you have to, obviously in order to do that, you have to figure out whether or not the mouse is inside of the button when it's clicked. And so because we know the X and Y position coordinates of the mouse, and because we're the ones who drew the button, so we know where it's going to be pressed, we can then use that to figure out whether or not the user's input is inside of, like I said, that button. So in order to do this, we would have to implement a bunch of if functions that simply check whether or not the given X value is inside and if the Y value is inside. And you have to check if both of them are inside, because otherwise, if only one of them is inside, then it might not be completely in. So let's try to implement this. Let's say we want to, for the Connect 4 board, let's say we want to implement a button that simply says reset. So in other words, a button that resets the game whenever you press it. First off, we have to draw out the button. Well, technically you don't need to draw the button, since you could just assume the user knows where it is and then just check the XY keyboard and input anyway. For like any actual, if you're actually going to use it, you definitely want to draw the button out so like the user knows where to click it without having to like go through the code. So let's draw the button at the very end of this program. Remember, when you're using Paint and draw things, the last thing you draw is always going to be on the top. So for the button, let's just make it a white button. We're gonna put in the top right corner actually. So so when we do here, we simply set the color to white and we draw a rectangle that has the X that starts at the XY coordinate 700. So it's going to start at that XY coordinate and it's going to draw, and it's going to have a length of 100, width of 100, and a height of 100. So that's how Java handles the coordinates. You give it one coordinate, one corner, the left top left corner, and then it'll go from there and simply use the width and length to draw it out instead. So now that we have this square, we can also label it. Like there. So now if you run the program, you can see we have a button there. And make sure you change the color between the button and the text. Otherwise, the text won't appear since it'll be the same color. So let's do that. Let's make this. Right. So you can see we have a little square in this corner and it has the word reset in it. So this is going to be our temporary button for now. Obviously later, if you are actually going to code this, you might want to make it look way prettier than I'm doing it right now. Right now, I just want to demonstrate. So in order to get the button to work, because right now, as you can see, if you press on it, nothing really happens. There's no indication of anything happening, at least. And even if we did put in a column, clicked it, nothing happens. So this reset button, right, it's going to reset the board to a a state that hasn't been played yet. So if you, in other words, if the mouse is inside of this button when it's clicked, then what you want to do is reset the board to an empty space. So in this case, we know that the rectangle is located at these coordinates. So we simply have to check if the most left corner is less than x, and if x is less than the leftmost corner plus the width, and you keep for the y corner. And you could try to do different methods. Like one other method, for example, is simply checking if the x1 coordinate is outside of the button and not running if it is, and otherwise running it. Or you could simply check if it's inside the button with multiple if loops. If you wanted to, instead of writing them all out like this, what you could do is also combine it into a single if loop with the Boolean operators you learned about in a previous class, specifically the operator like and, which combines two inequalities. It combines two true or false questions and uses both of the results to then output a new true or false value. So if you remember, and means you take the true false value on the left side and the true false value on the right side, let's say this one, and then you check them both. If they're both true, then you will also then, and this and function will cause it to return a true. If at least one of them is false, then this will return a false as well. So in other words, this if function will only run its interior if both of these functions are true, if x is both greater than 680 and less than 680 plus 100. And the same can be done for the y value. There we go. And now if it's inside, what like we said before, this is the reset button. So we want to reset it. So in other words, we simply have to one way you can do it is simply by resetting it to a new board of 6 and 7. So remember, the reason why this creates a new board is, remember, we're creating a new int array, new int 2D int array. So in other words, we're taking what board used to be and replacing it with a completely brand new int array. And since it's brand new, and we didn't give it a default value, then it's gonna use the ordinary default value for Java functions, for Java integer arrays, which is simply 0. So in other words, it's going to be a list of complete zeros, which in our program symbolizes the empty space. If your program was like formatted differently, like say used the letter 1 to represent empty space, then you might have to write it a bit differently. You would have to create a new int array and then fill that entire array with like ones. You could do that by like iterating through each element or simply using a pre-made method to do that for you. But since we already made it so that 0 is empty space and there's no reason to like change that, this helps us reset the board simply. So this will reset the board, but one problem it has here is that it doesn't repaint the board. In other words, it can reset the board, but the effects won't be shown on the actual graphics because the graphics still contain what was originally painted and have not been updated. So if you want to update it, you will have to tell the program that now after this is done, repaint the entire board. So we have an empty board. And if we click it right now, nothing really happens because again, the board is already empty. But if we were to play it a bit, so you can see now stuff is here. If we click reset, nothing happens. So here's one. So I told you guys all earlier that you should download IntelliJ, and one of the functions of a compiler like this is that it has a debugging method. And debugging essentially allows you to go line by line to check for any errors in your program. This is something I didn't get to show off earlier, so I want to show it off now. So essentially, you start by clicking a line, and it'll highlight it red, and the database tells the program when you get to this point, stop here. And then you have to click the debug button on the top right. Actually, let me put some extra breakpoints so it's easy to see. So you can see the program has not gone any further. Normally, when we tell it the number of rounds we're going to do, it immediately goes on to asking player one what column wants to put in. But see, it stopped here. That's because the breakpoint that we put at line 13 essentially tells it, when you debug it, tells program when you get to this line, stop. And then when you get to here, you can then simply either tell program to keep moving line by line, one at a time, or you can tell it to move on to the next breakpoint by pressing the relevant button down here. Each of them, if you hover over, you can see the exact name. It says step over means step over to the next line, and here it says resume program until it hits the next breakpoint. And you can see all of your variables and their corresponding values out here. This is really helpful for seeing what you like, seeing what the program is like doing right now and whether or not it's doing what you want it to do. Yeah. But that doesn't actually help us here, because the problem here is that this, even if we did put a breakpoint here and debugged it, it never goes to here because it's not actually being run. We need to yeah. Should just wait. Am I done about this? I know I could be done about this. I'm not. Let me see. Yeah. So see, even though we're pressing on the screen, nothing's happening. It's not going to this relevant method because it's not being called. Every time we click, it's not actually going here. So the reason is, all right. See, where is it? Here it is. So mouse listener, whenever you implement a mouse listener, auto calls the method for you, right? But that's not all. But you can't just run the method. You still have to tell the program that it has a mouse listener. It's simply implementing it, but doesn't actually have a mouse listener essentially. So specifically, it's essentially this tells program that not only does this area have the way to use mouse listener, but actually you have to actually add it to the panel itself, because the reason is these two methods right here, where it tells you whether or not the program actually, whether it tells you when the mouse enters or exits a window. Since you can have multiple windows, and sometimes you can have multiple windows within the same frame, you can't just simply implement it once for implement it for the panel. You have to add the mouse. Once you implement it, you then have to add it to each relevant window or panel itself. and then it'll know whether or not to track it for that panel window or not. So by adding it, by adding the mouse listener like this with the by calling add mouse listener and then telling program that this panel, like this refers to itself essentially. So this panel, Connect 4 panel, we want to add a mouse listener to it. And by saying that, the computer now knows, oh, you want, it's not only do you want me to implement the methods up here, but you want me to actually add a mouse listener to this panel. So as you see, when we clicked it, the red dot disappeared. So in other words, the board got reset. And if we were to click outside of said red circle, I mean, not red circle, sorry, if we click outside the reset button, nothing happens. Only when we click inside, because again, the if code tells us we only activate if X and Y is within the relevant area, then it will activate, otherwise it won't. And so mouse listeners can be very useful simply because a lot of computer input is done through mouse. So if you need to use the mouse like at all, it's basically like necessary that you implement and add a mouse listener and then use it in order to like get the user's inputs and then check to see where they are, where they're clicking, and like how they're clicking it. Of course, the main problem with the mouse listener is that, as you can see, if you try to code out all of like the relevant clicking areas by yourself, it can get very messy. You have to, for every single one, you have to implement an X coordinate checker and a Y coordinate checker, and they can go on forever. If you have like even 8 buttons, you'd have to do this 16 times, and so that's not good. So that's why there's a thing called, this is why instead of storing your buttons as just a simple, instead of just simply drawing it like this, you can use what's known as a polygon, which is specifically designed to auto implement a lot of these kind of messy methods. So essentially a polygon is like any other object. You create a container for it. In this case, we're creating a polygon container that's called a polygon. And we want to put a new polygon into it. So the way Polygon works is that it stores a list of points, a list of X and Y points, and then it uses that point to draw. So if you want to do the button down here, instead of simply just drawing out a rectangle like this, we would instead tell program that we want 4 points inside polygon. One at 680, 0. One at 680, 100. One at 780, 0. Now 100. And then one at 780, 0. And the program will draw in the order you add the points in. So by adding the points in this order, 680, 0, 680, 100, 780, 780, 0, I'll draw a rectangle because it'll go from point 1. I'll draw a line from 680, 0, which should be like which would be the top left corner of the rectangle. It'll go down and then we'll move to the right and then move up and then connect back to the last point. If you were to reverse the order of some of these, it would essentially cross over itself. So let's demonstrate. Okay, so first of all, in order to show, we have to actually draw the polygon. So fill polygon, and we simply put the name of the polygon in there instead of having to write out the size and like different points. And we just draw the word polygon. All right, so it looks fine so far, right? If we were to reverse the points, say by doing that, You see here, it got twisted. This is because when it draws a line between each point, it starts from the first point you add to it, and it's going to move to 780, 100, which is the bottom right point. And it's going to move over here and then back up to here. And then when it fills in, it's going to only fill in the area contained by these. And since the lines are crossing rather than shit like that, then it's not going to cover these areas. Of course, in other words, the order is important. So you can't just put it really nilly and expect it to always be like a filled in rectangle. So this is both, this is also going to be really helpful in a lot of situations where you want to draw shapes like this, but otherwise, but essentially it's important to remember that you want your points to be in order. All right. So the thing about polygon is not only does it allow you to have done that, not only does it have to prevent you from rewriting all your points again. If you want to draw the polygon again, you simply have to write the word polygon. When you use mouse clicked, instead of having to do it this way, you can use the polygon method, where it's essentially where you simply call it polygon by name. So you take the word, like the name of the polygon, which in this case is just polygon, and then you tell it whether or not it contains. You tell it to use the method contains, and contains simply checks whether or not a given x and y point is inside, and it will return true or false. So in this case, what we'd have to do is, first of all, we would have to move this one. We have to move it outside because remember, variables, the Java and all those other programs have a specific area in which like the variable actually exists. In other words, specifically, it's called scope, and most things only exist within the brackets are created from. So specifically, any variables you create within this bracket will only exist in this bracket. So like this int draw y, you can't access it outside of these brackets because it doesn't exist out there. If you want to use it, you have to put it outside the bracket. In this case, by changing polygon position to the outside, we can then use it inside both the paint method here and the draw method here. Like that. Yeah, this is a extremely important concept to know. I did talk about earlier, but it's been some time. So essentially, scope means any variable or any function you create only exists within their respective bracket. If you move outside the bracket, it doesn't work. So if you want to use it outside brackets, you have to then move it until it's within the area you want to use it in. The reason we don't move everything outside is because sometimes we don't care about the variable all the time. Like x, y, we only care about it inside this area. So in other words, if we're doing any function outside of the mouse clicked function, we don't need x and y, and thus we can get rid of it, which essentially helps save memory. And while for small programs like this, that won't matter too much. In larger programs, memory is pretty essential. And you definitely don't want your program to be using like excessive amounts of memory. Yeah. So now by putting polygon outside, we can use it inside both of these methods because it's no longer contained by these brackets, but contained by this bracket instead, which covers way more space and also contains both these methods. And so we can simply use the polygon method contains, which returns a true or false value, depending on whether or not x and y is contained within the polygon. And then by doing that, instead of having to write out the entire x less than, x greater than, y less than, y greater than, we simply use that and it helps shorten it considerably. So that's how essentially say how you might code a makeshift button. And essentially, this is essentially how you would use mouse inputs in Java, where you would use the mouse listener, use the mouse listener's variable where object where it will and it contains the x and y values, which you can use the methods to then extract or get, and then use those x y values to do things depending on what they are. And then usually you will probably have to repaint it in order to show that something is happening. Another form of the repaint you also repaint it, say, have a repaint mouse press release to repaint the button, showing it being clicked and not clicked as well. There's also a lot of other functions that can also be used inside panel. Specifically, Java has its own button object that you can use instead of having to code your own. And I'll put in the Google Classroom when we're finished. But yeah, so Java also has like a default button you can also use. And you simply create it by creating a variable called JButton, give it a name, and talk into a new button. And the text inside is simply the name of the button. And then like mouse over center, you have to add the button to the actual panel. But of course, you can't just add it. You have to make sure that you have to give it the relevant position and size first as well. So if we do it this way, uh, mm, or we could do what was it called? This is much better. There we go. All right. So essentially, in order to use JButton, you have to set like the bounds. In other words, its actual size and the area it takes up. Add it to the frame, so add it to the panel, so it knows which window it's placing access to. And then you have to add an action listener, and this just basically means what happens when it's pressed. In this case, it's going to call the reset method, which just resets the board to a new board. As you can see here, we have a much more proper looking button now. And so it's lots of these more specific things, like the specific types of things you can do, such as bound stuff. You'll have to essentially, this is what we program is called Googling. So one of the more important parts of coding that you'll find yourself having to do a lot is essentially referencing online, like the online documentation, like the program, essentially the programming wiki, in order to actually because like all the languages have huge amounts of functions and libraries that they can do. And while you could dedicate like 40 years to memorize all of it, it's usually way more efficient to just know what you need and then just simply be able to search for it. For example, JPanel, specifically the thing that gets essentially the Java library contains the various things like JButtons and JLists that you can use to implement inside of a panel and simply have to draw it out yourself. And most of this, and basically all this documentation can be found inside the official library of whatever programming language you're using. In Java's case, you usually want to look for docs.oracle. You want to look for Oracle, which is essentially like the official
website containing all the Java documentation and whatnot. Because there's way too many functions inside to individually teach every single one of them. So while you want to memorize the most important ones, like the for, while, if loops, along with the basic ways of creating method programming stuff, the most important thing is being able to identify what you need and being able to search it up yourself as well. More specifically, for example, if you want to use the keyboard presses, the keyboard can one way the program handles keyboard input is through ASCII, which is essentially the program translating a keyboard's input into numbers, and the numbers don't really seem to correlate with whatever the actual letter character is. Like uppercase A is associated, can also be written as the number 65. So again, in order to actually utilize ASCII well, you probably have to, you can memorize the most important landmarks in ASCII, like how uppercase A is 65, but it's generally more useful to simply be able to find the actual ASCII chart online and then be able to actually compare characters with numbers. So yeah, essentially what I'm doing right now is giving you the ability to not only code any framework and any framework and any basic programming need, but also by giving the ability to find out what you need and what you actually might need to actually create later. So for example, there's also, not only is there a mouse listener, but there's also mouse motion listener, which rather than simply listening for clicks, listens for the motion of your mouse. So essentially will essentially do an action all the while your mouse is moving. And that's really similar to mouse listener, except just implements slightly different methods that only activate when your mouse is moving rather than clicking. Yeah. So that's essentially what, this is essentially most of what you need to know about frames and panels. Frames and panels allow you to display actually display the program and what it's doing by essentially creating a frame and then creating a panel to put inside the frame and then coloring the panel itself with various things, such as manually drawing out each shapes, or simply using the various already created things like JButtons. And you can also draw images as well by simply calling the relevant method. Like also draw images by creating image objects and storing images inside it, and which will normally have, and essentially what the image object just stores a file, usually like any JPG or like JFIF or any image file. And then you can use that, and then you can use g.drawImage to just draw the image file in the relevant position as well. Again, you can, as you see, whenever we type things and whenever we want to call the relevant method something has, you can see there's a lot of methods. So while the most important ones we've already seen, if you ever have trouble, like if you don't know what any of them means or anything, you should definitely look online for it. There's one more thing about drawing that we need to learn, and that's about fonts. In other words, essentially, if you want to draw words, essentially, while we already showed how to draw default words, which is just draw a string, and then you give it a string, and then the position, and also how big this string should be. So just use it. However, if you want to use different fonts, different sizes, and stuff like bold stuff, the way you do that is very simple. You simply tell it create a new font, and then simply apply that font to the current program. And to create a font, like any other object, you create a holder for that font. Give it the ability to hold fonts by titling it appropriately and setting it to contain a new font. And when you create the font, you have to give it the relevant identification. So like the font needs specifically a name, a size, and whatnot. It's going to be bold, italicized, or simply normal. So for example, I believe it was Yeah, pretty sure this is the name of the font. And then you have to give it C. So essentially, you essentially first name the font. In this case, it's just Times New Roman. We tell it whether or not it's supposed to be plain or bold. You can access the essentially. You have this here actually requires a number, which and each different number essentially just signifies a different type of font. But we can access like their pre-made number that's stored in a variable by simply looking for it inside the relevant methods that can get essentially you can access one of their public variables bold by simply accessing it through the font. Essentially create a new font. It's called Times New Roman and it's plain, so it looks like normal font and has a size of 18. And so this is essentially how you decide the size of fonts. Fonts, as you might have noticed, don't get the extra 2 numbers at the end, representing a size like the ovals and rectangles did. Instead, the size of font is entirely determined by the actual size. The size of the string is entirely determined by the size of the font. And then to actually use the font, we simply set font similar to how you would set color. Let's make this more obvious. As you can see, it's kind of hard to see, but there is a font up there. So let me change the color bit. Add done. Yeah, it's a bit more obvious now. It's actually leaking, like being covered by the top because the size of the font is way bigger than the actual like area we give it. It's only 10 places down, but since it's the size of 28, it extends past the screen. Yeah. So essentially, as a probably the final review before we do something else is remember this specific program involves 3 things: input, operations, and output. And the two main input methods you learn are scanner, which can get you text from the terminal, and mouse listener, which allows you to get inputs from the users clicking the mouse. There's also various different other implementations, like I said before, mouse motion listener, which listens for the motion mouse, and there's also key listener, where instead of having to type into somewhere, you click your keyboard at any time and it'll automatically register. For example, if you were coding a game and you want to use the WASD keys for movement, you would have to use key listener instead of using scanner, because you don't type things when you use WASD. You simply just press the key and then program will automatically do something based on that. Key listener works very much the same way. It automatically implements key methods, and then you have to add it to the actual panel itself. Mouse motion listener works the same way. And finally, and then also the frame, which again just simply allows us to actually create a panel. Is there any questions about Connect 4, or are you guys feeling okay with it? Anything you want me to like re-elaborate? I know I talk a bit fast. If you want me to slow down too, that works too. Any questions though? So today I want to talk a bit more about data structures, especially specifically things like variables and objects and other ways to store information in Java. So in other words, the two main things we learned about is variables, specifically primitive variables, which hold only a single value, so things like, for example, when you create an integer variable, you tell the program this is going to be an int type variable, you give the variable a name. then you set it equal to some number. Like 9 in this case. Essentially, the program knows, okay, so this is a variable, it holds integers, and right now it's going to be holding a 9. And you can use the equal sign to replace the number inside. So if you were to write this instead, it would replace the 9 with an 8. Or if you, and double equals is what you use to actually compare two numbers. So if you wanted to get a true or false value, then you would have to use double equals. Single equals means assignment. In other words, it's going to replace the value. You can also, and that's essentially also how you change the value. If you want to increase it by 1, you essentially have to write out the variable, reset the variable to a new value, which is equal to the old variable plus 1. So that's how you would, and so that's really the only way you can change the method. Since it's not really changing the actual like number itself, rather you're simply replacing it with a new number. It's just an adjustment of the old one. And then we also have different types of these containers, like doubles, which holds not integers, but decimal numbers. Whereas integer variables cannot hold decimal numbers. If you try to give it a decimal number, it'll automatically round down and get rid of the decimal. And we also learn about strings. And it's basically, so essentially primitive variables are essentially ways of storing single values, single simple values, like usually just numbers, but also things like strings. There's also character, which holds a single letter rather than a string, which holds multiple. And all of these can be compared to each other. We're using double equals as well. We also learned about objects. And actually, you might have noticed that string here, like the string, the string text here is white, but all of these are orange. And to get a string, it's kind of weird. It's counted as both a variable and object sort of in Java, where you can assign it values like a primitive variable, like int, double, or character, but it has its own methods and stuff, which makes it more of a object. So specifically, objects work very similarly. When you create an object, you have to call the object's type, like if it's a scanner type or one of your own custom types, like essentially like the frame and panel I made earlier. So if you wanted to create a scanner object, for example, we would have to tell the program we want that this object is going to be of a type scanner, so it holds scan. So it's going to hold scanners. You have to give it a name so that so the program knows what to reference it by. And then we have to set it. And now, right now, what now? If we just wrote this, what it's essentially doing is we created a container that can hold a single scanner object. In order to actually have a scanner object, we have to use the assignment operator again and give it a new, and then create a new scanner object along with the necessary inputs and if it needs it. And now instead of an empty container, it's a full container that holds a single scanner. And again, the assignment operator works very much the same. If you use it again, then it will replace the old scanner type with the new one. The main difference between these objects like string scanners and ones we made ourselves and the primitives is that primitives hold single values and you can use a double equal sign to compare them. Whereas these objects often hold like multiple values and can also have their own methods and stuff. Essentially, if you were to write it out as a class, and what this does is it can only hold a single piece of data, whereas the classes we wrote, right, the object we wrote, they can hold multiple pieces of data. Here it holds one int list into the array that's called board. It holds one polygon that's named polygon, and it also holds a splitter. So it holds this specific object holds 3 variables, whereas something like scanner might hold like 5 or 6, depending on how like the code inside of it actually works. They also have constructors, which is how you actually create a new object. Remember, when we call a new scanner, we also have to give it an input method. And so this input method is what happens in this constructor. Whereas instead of having a 2D array here, the program instead needs a input method here. And finally, they have methods. So like we said before, Scanner has all of these types of methods because inside the Scanner class, it's been coded inside. Like Connect for Frame has a method code inside setBoard, and you can access it by simply calling the name of whatever you stored the frame in, and then calling the relevant, and then simply writing out the relevant method after it. String as well also has these various methods. Like method, they have the length method, which is length split, which splits the list into a string list. In other words, essentially, instead of creating an int array, which holds a list of integers, you can split it into a list of strings. For example, if you gave it a sentence like, I like cakes, you could split it like this. And what this essentially means is that you're going to split it depending on whatever is inside. So right now what's inside is a single space. So it's going to look for every space, split it there, and then create a list based on that. So in this case, it would create a list of 3 elements. Element 1 is I, element 2 is like, and element 3 is case. And then I'll assign that, and I'll output that value, and then you have to take that outputted value and then do something with it, such as storing it inside your own list to use it later, or simply by or simply if you just want the first element, you can just access it like that and do it that way. Yeah, essentially that's the main difference between objects and primitive variables. And primitive variables store one value. You can only primitive variables can use the double equal sign to compare, whereas you cannot compare these with double equal signs. You have to use specifically the equals method we talked about in second class. And equals is essentially used to compare two objects. Normally, you want to use compare 2 objects of the same type, because if you do different types, then this will never mature because it's of 2 different types. So you compare 2 strings. The only way to truly compare them is by using the equals method. Whereas with primitive variables, you can use equals. This is mainly because the main difference is because this is the actual value itself, whereas this is a pointer, and comparing pointers is different from comparing the actual value. But that's more of a it's not really necessary to understand how it works. Yeah. So whenever we essentially what we did when we created the frames and panels is we created our own object called our own object, and we called the object the connect for panel, which is essentially how the program recognizes the type. It's saying you're creating an object and the type is going to be a connect for panel. So if you create an object of this type, it knows it's going to be a connect for panel, and it has its own, and then it will initialize or create the necessary variables, necessary methods, and then run them whenever needed. And whereas these are essentially just the very base foundational building blocks of everything, where they don't do anything fancy, then they just store simple stuff, but they're still necessary. Also to note, things like the arrays and stuff are still counted as essentially, they're not exactly single primitive variables, but they just contain multiple primitive variables. So it's pretty similar in anyways. So like something like this would also still be, as you can see, still essentially counted. The way we create an int array, however, as you can see, we're using a new keyword here. So while it is just containing primitive variables, it's still constructed like an object. This is still an object because again, we're not holding single data points anymore, we're holding multiple. And like objects, has its own methods. Specifically, arrays only really have two methods, and that's equals and length, which again, one of them tells you length, another one tells you whether that's equal to something else. But the way arrays work is that you want to use the arrays class, you want to actually use the arrays method. So you can see here, there's a lot more methods, and this is what you actually use. Because arrays are like a mix of primitive objects, because they use the methods are actually split outside of the array, because essentially there's no class called array, because the array is created using like a primitive type first. So there's no class called array. So you have to instead Java has an entirely separate class called arrays, and use this class or use the methods. For example, if you wanted to fill an int array, it's essentially fill means you take an array and then you change every element to some number. In this case, we wrote 2, so it changes every element to 2. In other words, if you want to use anything other than the basic length and equals method, you have to use the arrays class and then use its own built-in thing. For example, if you wanted to sort the array from least to greatest, you would have to call the array and do this sort method, or use its own equals method instead. Arrays is really the only one that works especially like this. The only other ones are things called collections, which is a thing specific. The most common one is array lists. Which are essentially just lists, but instead of having to tell the program how big they are, they automatically adjust their size to every time you put or remove an element out of it. Except they usually take up a lot of memory and are really slow. But these are one of the only other things you'll commonly encounter in Java that also needs you to use an outside method to that also need an outside method to do things with. Like in this case, it's basically collections. So it's only the arrays, only the list arrays and stuff like that, the things that hold multiple variables work like this. Mostly because of the fact that they aren't actual separate objects, but they're objects or that contain other objects. So they have to use a separate class to actually use the pre-implemented methods. Yeah. Whereas simple single objects can just access the methods from their own just by calling their name instead of having to call the separate class. You could do the same for these, like instead of using new scan.nextInt, you could also try calling just nextInt if it had a method that was implemented that. Scanner doesn't actually have a method with that. Specifically, the class called arrays has a static method that does it, but scanner doesn't actually have a static method like that. Yeah, strings, however, strings, however, do also have this function of having extra methods implemented inside the class itself that aren't available to the method, to the actual variable declare, which is essentially the difference between static and non-static, where static is only available to the class and non-static is it's available for each individual new object. Essentially, if you create multiple strings, they all contain the non-static methods, which are just methods exclusive to each individual string that can be used, that usually just deal with the string itself. But if you want to use the methods that's relevant to every string, like for example, length is a method that's unique to every string because every string can be of a different length. But something like, so in this case, value of, what value of does is it takes something that's not a string and transforms it into a string. And because this method is not specific to any string, because you take an outside method anyway, this is a static method. So it's only relevant, it's only usable by the class itself rather than by the string itself. All right. That was kind of all information class, but for our next and final class, we're basically going to do a giant review of everything we've done all the way till now. I'll put all the code and stuff on Google Classroom, but other than that, that's our time. So see you next time. If you have any questions, you can stay behind.